Better.
Nice. So Angeros will be late, Adam said. We are waiting for Neil and Valentin also. I'll wait just 2 more minutes and we'll start.
Romans.
Hello. Okay, maybe Neil will be late too. So we'll continue with the modeling, the different types of models that we started last time on Tuesday. What models did we discuss on Tuesday?
Okay.
What models did we discuss on Tuesday?
We discussed about the linear equations and quadratic formulas.
We discussed linear models and quadratic models.
Yeah.
Okay. Now we will continue with the next one. You can see it, right?
Yeah.
Yeah.
The linear models, piecewise linear models, we discussed a little bit. And quadratic models. Okay, we'll start with question 8, just to review what we did last time. How do we start? The owner of a business believes the weekly profit of the business can be modeled by this quadratic function, where x is the number of items produced, and you have the following data. When x equals 50, p equals 1350, x equals 200, p equals 5100, x equals 400, p equals 3100. Write down three equations in p and x. How do we start? What do we do here?
Probably that when x equals 50, p equals 1350.
What do
Then
we do with them?
write them down.
How? How do we use them?
Probably to create 3 points and make a line.
No. Of
Hmm.
course you can. But how we know, not we know, but the owner believes that the profit is modeled by a quadratic function, that is ax squared plus bx plus c. How do we use this data given in the table to find a, b, and c? How can What's the relationship between x and p and abc? What did we do last time?
Oh, we're gonna get the system of equations
And how do we get there?
by substituting the x and p values and then turning them into linear equations.
Nice. So, does anybody need me to write it?
Yeah, sure.
Okay. So, just a second. So we have given that we suppose p equals ax squared plus bx plus c. And we have that when x equals 50, p equals 1350, and x equals 200, p equals 5100, and when x equals 400, p equals 3100. So when we substitute the first pair, 50 and 1350, we will have that 50 squared times a plus 50 times x plus c, 50 times b, sorry, plus c will be equal to 2350. For the next one, when x equals 200, we will have 200 squared a plus 200b plus c equals 5100. And for the last one, 400 squared A plus 400B plus C equals 3,100. When we square the numbers at the beginning, we will have that 2,500A plus 50B plus C equals this. Then 40,000A plus 200B plus C equals 5,100 and 160,000 A plus 400B plus C equals 3,100. What do we need to do before solving it with GDC?
I think the equation to equal to 0, right?
Yeah. So we first need to move the free terms at the other side, and then you use your GDC.
Morning, miss.
Morning.
Sorry for being a bit late.
Not a bit, but okay. Didn't you come? No. Okay. So now use your calculator to solve it, and I'm waiting for your answers.
Wait, is that a simultaneous equation?
We are doing question 8 from the presentation. I switched the screen. You will see it later. It's about quadratic models that we did last on Tuesday.
Okay.
Okay, miss, I got 3 values.
Mm-hmm.
0.1, minus 50, and 900.
Did everybody? Sorry. Did everybody get it?
Miss, my calculator says this variable is not defined.
For linear equations, that's almost impossible. But
Miss,
Okay, let me try again.
I got 0.1 minus 900 and plus 50, positive 50.
Okay, let me check. We are waiting for some other answers then to see. Anybody else with different answer? Bartek, isn't a minus 0.8, 0.1? Can you check how you entered the coefficients there?
Sorry, could you repeat real quick?
Isn't a equal to minus 0.1? Can you?
I can show you.
Yeah, okay, but can you check how you entered the coefficients? Bartek, the easiest way to check if this answer is right is when you substitute these three values in the first equation, they don't work. So something is wrong with your coefficients, maybe? Just check how you entered them.
I mean, I can't really find a mistake. I wrote down the same values.
Because I got minus 0.150 and I'm still on C.
I can show you my calculator. I mean, I put down these values. They're correct.
Just a second. And C equals negative 900. Switch between the let me see now. 51, 40, 100, 200, 200, 1 minus. In your case, look at the equation at the beginning. Your calculator does not require 0 to the right-hand side, which means that for you, D is positive. All the numbers 375, no, the free terms. For your calculator, they should stay at the right-hand side and they stay positive.
Okay, I see.
Bartek, did you get it? Did you get the right answer?
Yeah, now it's okay. Now it's okay.
So we got minus 0.1, 50, and minus 900. So the next question was, write down the three equations in P and X. We did it. We simplified them. Hence determine the values of A, B, and C. We just did it. Interpret the value of C in this context. Looking at the quadratic model, what is the value? What does the value of C tells us? When is P equal to C?
At x equals 0, I think.
Okay, so the value of C shows us what's the profit if you do not produce any item, because X is the number of the items produced. So if we produce no items, the profit will be equal to C. Our C is minus 900. So the profit will be minus 900, which means actually that is a loss. Okay? Questions?
Yeah, all clear.
Okay, and find how many items should be produced to maximize the profit. How do we find it? The easiest possible way, I
Graph.
hope. Okay. You use your best friend, the calculator, you graph it, and you find the coordinates of the turning point or the vertex. The x coordinate of the vertex is the answer of D1. The y coordinate of the vertex is the answer of D2. So what are the answers for D?
One second. It's at x 250, y 5350.
X 250, Y 5350. So after we found A, B, and C, this means that the profit function is actually P equals minus 0.1 x squared plus 50x minus 900. When you graph it, you will see that the coordinates of the vertex are 250 and 5,350, which means that the maximum profit is 5,350 when she produces 250 items. If she produces more than 250 items, the profit will be less, actually. Okay, any questions on this? Any questions on this?
No.
Who disappeared now?
Not really.
Sorry?
No question.
No questions yet.
Yeah, but who disappeared?
I don't know.
You're one less. Adam Anastasia Angelos. Bartek David Joel.
Nastya disappeared. Oh, no, she's here.
She didn't.
Here.
Ah, Grisha.
Yeah, Grisha.
Okay, so back to the modeling. Then to the next type of models, exponential models. The exponential model has the variable in the exponent or power, and it can represent exponential growth or exponential decay. The exponential growth looks like the picture to the left. The exponential decay looks like the picture to the right. And all the exponential models have a horizontal asymptote. What was asymptote? What does asymptote mean?
It's a straight line at which the line never meets.
But goes approximately close.
Yeah, it goes infinitely close.
Goes infinitely close to it, but never intersects it. So they all have a horizontal asymptote, which the curve approaches on one side. So for the exponential model of the form, this is the general form of the exponential model. You can write it down. Y equals k times a to the power of r times x plus c. And basically here, when the coefficient in front of x is positive, it is exponential growth. When the coefficient in front of x is negative, then it's exponential decay. And from the general form, you can get the horizontal asymptote, that is y equals c. It is the asymptote because y can actually never become equal to c, because this will mean that the first part with the exponent should equal 0, but no number to an exponent gives you 0. That's why y equals c is the asymptote. And the y-intercept, how do we get in general y-intercept of a function algebraically?
When x is equal to 0?
When x is equal to 0. That's why when we put x equals 0, all the first part here in the general form will disappear as a to the power of 0 equals 1. No, not all the first part, but a to the power of 0 equals 1. So we will have that y equals k times 1 plus c, which is k plus c. So when r is positive, it's growth. When it's negative, it's decay. The horizontal asymptote is y equals the free term, y equals c. And the y-intercept is always k plus c. Questions?
No.
Wait, I didn't quite understand the exponential growth and exponential decay. When what is positive, what is negative? I didn't understand that.
It is written here when r is positive, the coefficient in front of x. If it is positive, then it's growth. If it is negative, then it is decay.
Okay, 1 second. I have to copy this.
Actually, you have to copy everything, but okay. Good morning, Neil.
Morning, miss. Hello?
Huh? Can I go further? I mean, did you copy it? Okay. Questions by now?
Nope.
Okay. Sketch the function 10 times 3 to the power of minus x plus 2, labeling the x-intercept and the asymptote. Again, to be clear, when they say, sorry, when they sketch the function, this means to graph it with your calculator and then sketch it on your paper, notebook or exam paper or whatever, not being precisely accurate, but to be as close as it's possible to the graph on your calculator. The basic point is the labeling. So you copy the picture from your calculator, but you should label the axis-intercept and the asymptote. What is the asymptote here?
2.
2. If you answer just 2 on an exam, you will have only one.
I mean, y is equal to 2.
Y equals 2 because it needs to be equation of a line. So the asymptote is y equals 2. And what's the axis-intercept? Y-axis, of course.
It's 12.
It is 10 plus 2, that is 12. So you should have a graph like that.
So is it the A, not the A, but the K plus the C?
Yeah, that's what was written here.
Okay. Thank you.
So as I said, your calculator will give you the graph, the shape of the graph, how it looks like. You copy the graph, but it's up to you to label it. Especially for the asymptote, I think the calculator doesn't have the option to show you the equation of the asymptote, but you can explore. Maybe it can. It can show you the intercept, but you can also calculate it by yourself. You're supposed to label your sketch like that. Okay?
Wait, okay, miss, I understand. I got the graph, but could you give me another explanation why the y-intercept, the horizontal asymptote is y is equal to 2? Because I'm a little lost, miss, on that.
Is it possible for y to become equal to 2? Looking at the equation.
No, because even if x is equal to 0, there's always, okay, yeah, makes sense.
Okay.
Yeah.
The first part, the exponential part, can never become 0.
Mm-hmm.
Number to any exponent is always a positive number. It never becomes negative or 0. So the first part cannot become 0 and y cannot become 2.
Yeah.
Any other questions?
No.
The others? Okay, now try this one. I'm waiting for suggestions how to solve it. And you can copy it down because I will switch to the board.
One second.
You can plug it in.
Ready? I'm switching.
We make simultaneous equations.
How?
Substitute.
How?
We substitute the value of x and y.
So for
which
1 and 4, what do you get?
you get 4 is equal to 2k plus c.
Okay, I'll write it like more. A times 2 to the power of 1.
Yeah.
Plus c. For the next one, it is what?
10 is equal to k times 2 to the power of 2.
To the power of 2 plus c.
Yeah, it's a simple simultaneous equation.
So for the first one, we will get that 2k plus c equals 4. And 4k plus c equals 10. You can use your calculators to solve them or just solve them by hand. It's up to you. Be careful what your calculator wants you to do, to move the 4 and 10 or not to move them.
Shut up.
Oibe, what?
Ange is.
No, not for you.
I hope so.
It's 3 and minus 2.
3 and?
Minus 2. That's what my calculator said.
Okay. The others, did you get them?
Oh, yeah, it's 3 and minus 2.
Okay. So this means that y equals 3 times 2 to the power of x minus 2. And then find y that the model predicts when x equals 4. How do we find it?
Oh, we just substitute again.
We just plug it
X, plug it in. Yeah. So
So
x is, I mean, it's going to be 16 times 3.
2 to the power of 4 minus 2.
16 times 3, which is 48. 48 minus 2, which is 46. Yeah.
So y equals 46. Questions by now?
Nope.
Why the question is stated like that? Find y that the model predicts.
Huh?
Why is the question stated like that? Find y that the model predicts when x equals 4. Why is it not like find y when x equals 4? Actually, there is something that we will go deeper next week, but why is it stated like that? Why is it not just find y when x equals 4? What do models do, and can we rely on them for all the values? Real life models, I mean. Creating a model for real life
They're all
situation.
estimates. They're all estimates.
Yeah, there's too many
factors. So we use some values to find the model, but this model is not 100% reliable. But it estimates, it approximates the values. That's why they state the questions like that, find y that the model predicts, because we cannot be sure that in the real life for this situation, whatever it is, the y will be equal to 46 when x equals 4, but maybe it will be pretty close to 46. Okay? Questions?
No.
Okay, exponential growth and decay models can be used to describe how quantities such as population size, amount of radioactive substance, or temperature of a liquid vary with time. And there is some common terminology you should understand in this context, but I'm sure you know it. The first one, at least you know it. The initial value is when t equals 0. and it corresponds to the y-intercept of the graph. Long-term behavior, and this is the thing that we are estimating mostly, actually, long-term behavior refers to the value of y when x is extremely large, like when x approaches plus infinity. And this corresponds to the horizontal asymptote of the graph. So when x is large, extremely large, y is very, very, very close to the horizontal asymptote. And we assume that if the process continues infinitely long, then y becomes equal to the horizontal asymptote because it will be this close to it that it should be estimated to this. Did you get it?
Yeah.
Okay, let's try this. The temperature of a kettle at a time t minutes after it has boiled is modeled by this exponential model. At first, is it growth or decay?
Decay.
Decay, because after it has boiled, its decay, it decreases. So, what's the initial temperature of the kettle?
20
20,
degrees.
because it's when t equals 0. What's the temperature after 10 minutes?
1 second. $49.4.
Oh. Okay.
Degrees.
Yeah, that's the same.
Is it not right?
The others, what do you think? I don't think it is.
I got the same value.
Okay, so it is. My bad. Sorry. So we find it when we substitute t by 10. Right?
Mm-hmm.
Yeah.
Okay. What is the temperature after? No, we did this. Sorry. How long does it take the kettle to cool to 30 degrees? How do we find this?
We make the whole equation equal to 30.
And how do we solve it?
That's a very good question.
So, we spoke about this. Okay. You have to solve 80 e to the power of minus 0.1 t plus 20 equals 30. The best possible way here, because you will use one and the same function for all of it, just graph the function for t with the calculator, and then graph the line y equals 30 and find their intersection points, because that's what equations actually are.
Yeah, that's much easier.
Mm-hmm. That's why I keep repeating that the calculator is your best friend on this subject. Because you are allowed to use calculator on both papers, so whatever can be done with the calculator, just do it. By the way, when you said that the initial temperature is 20, are you sure it is 20?
Now that I think of it, it is not.
The initial temperature is when t equals 0, but then 80 stays.
Yeah, 80 stays, so it's 100.
No, that makes sense.
Yeah, my bad.
And the temperature after 10 minutes is 49.2. So how long does it take the kettle to cool to 30?
Ade Bartolole.
Why
Hi
him?
there, and GJS, you do it too?
Angiros, if you don't have your calculator, just use another graphing software. Why Bartek?
Okay, I'm doing it. No, miss, I don't know how to put like multiple graphs into the calculator. 1 second.
That's good. How can you deal with this? You don't know how to put multiple graphs. How can you do it using just one graph?
Oh, just okay. Just put equals to 30.
I think it won't work. How can you use just one graph to solve it if you don't know how to put two graphs? You have the equation 80 e to the power of blah blah plus 20 equals 30. Can you transform it to one graph?
I mean, I believe you can. Of course, there has to be a method.
Did you write it down? 80 e to the power of whatever plus 20 equals 30. How can you transform it to not to have this much numbers?
Maybe I just take the 30 to the other side.
Exactly.
Yeah.
You will get 80 e to the power of whatever minus 10 equals 0, which means that you can draw this graph and find x-intercepts of this graph.
All right. Okay.
We're discussing how Angiros can do it without drawing two graphs. Bartek, do you have an answer?
Yes, miss. Am I unmuted right now? Because my Google Chrome is frozen.
Nope, you're not.
Okay, so can you hear me?
Yeah.
Okay, the two answers I got is x equals 20.8 and y equals 30. And the other one, actually, no, there is no other one. Yeah, because it's not a parabola. So it's just that 20.79 and y 30.
Which means that t is 20.8 to three significant figures. So it takes 20.8 minutes for the kettle to cool to 30 degrees. Okay? The others, are you going to leave me discuss it only with Angiros and Bartek? By the way, right after we are back face to face, you will have test. Okay. So, stating any assumptions you're making, deduce the room temperature when where the kettle is kept. And this is referred to the last thing from the previous slide, long-term behavior. So if we assume that nothing else changes, that the material that the kettle is made of doesn't reflect the temperature and so on and so on, if we leave the kettle infinite time like that, the temperature will be equal to the room temperature. So this approaches the horizontal asymptote. So the room temperature where the kettle is kept should be exactly the the horizontal asymptote, sorry. So it should be equal to 20.
Wait, miss, could you run that over again? I didn't understand. Why is it the y-intercept, the room temperature?
The room temperature, this is the thing that will, at first we are assuming that it cannot go below the room temperature first. And if you leave it infinite time like that, it will reach the room temperature.
Okay.
And this is when t goes to infinity, approaches infinity. And that's when the capital T approaches the horizontal asymptote.
Okay.
But again, this is assuming that the model can be applied until the kettle cools fully. We don't know how the material of the kettle reflects the temperature and so on and so on. But using the model, according to the model, the room temperature is approximately 20 degrees. Okay?
Uh-huh.
Yeah.
An important feature of exponential models is that a constant increase or decrease in x results in y increasing by a constant factor. For example, if y equals 5 times 3 to the power of x, for x equals 0, y is 5. For x equals 1, y is 15. For x equals 2, y is 45. Because actually, increasing the exponent of 3, we are multiplying by 3 more. So y increases by a constant factor. This looks like geometric sequence. It's very similar to geometric sequence. The difference is that in the geometric sequence, we could have in the exponent only positive integers because they represent, the exponent represented the number of the terms. Here in the exponential model, x can be any real number. That's the difference between geometric sequence and this. So if y equals k a to the power of x, to prove that y increases by a factor of a when x increases by 1, we can just write step by step. When x equals x1, y equals k a to the power of x1. When x equals x2, that is x1 plus 1, because they want x to increase by 1. y2 equals k a to the power of x1 plus 1, which is a to the power of x1 times a to the power of 1, which is a y1. So when 1 is added to x, y is multiplied by a. Actually, you don't need this proof, but it's interesting. Okay, let's try this one. The number of people in the world with a mobile phone, n billion, is modeled by n equals 4.68 times 1.02 to the power of t, where t is the number of years after 2019. In 2019, how many people have a mobile phone? How do we find it?
I equals 0.
T equals 0 because that's the moment at which we start using this model. So when t equals 0, what's n?
Uh, 4.68 billion.
4.68 billion. So in 2019, 4.68 billion people have a mobile phone. Then the next one, what's the yearly percentage increase in the number of people with a phone predicted by this model?
2%.
How did you get it?
Miss, it's just times 1.02.
So what? I know what it means, but I need you to explain it to me. This is just guessing if you don't explain it.
No, miss, I am okay. So basically, when you multiply something by 1 itself, miss, you get the value you multiplied it with. But basically, when you increase it by 1.02, that means you're multiplying it like times 102%. So basically,
Okay.
you're adding 2% to the initial.
Okay. The others, did you get this?
Not at all, miss.
When you multiply by 1.02, you can recall how we did the compound interest. When you multiply by 1.02, this means that you multiplied by 102%. And 102% means that you increase by 2%. Because 100 is the initial value, 102% is 2% more. Got it?
Yeah, now it's clear, miss.
Okay. Questions?
Nope.
And how many people does this model predict will have a mobile phone in 2025? What do we need to do here?
Plug in 6.
Yeah, t equals 6. Because 2025 is 6 years after 2019.
It's 5.27 billion.
5.27 billion. Questions?
No.
Okay, now try question 14. Try to do it by yourself and we'll see what will happen.
The equation is going to be 8,500 times 0.8 t,
Yeah.
and then it's going to be worth $912 after 10 years.
$112.
900, sorry, 900. My bad.
$912. Okay. Then continue with the last part. How do you solve the last one? Any suggestions for the last part?
Probably gonna be plus 500 on the end.
Yeah, but why? Can you argue it? No, reason it mathematically.
Because the line is gonna, the asymptote is gonna be at 500. That's the lowest value that any car can have.
Because they say no matter how old it is. So this is the assumption that the time approaches infinity. And when time approaches infinity, we go for the horizontal asymptote. So
Let's have a question. When time approaches infinity, the value of the car becomes zero, right? No. I mean, the value of the car itself, but like excluding the fact that they get $500.
because they give you a new model and because the company guarantees to pay 500 for any car. Doesn't matter what the value of car is, doesn't matter how old the car is, they will pay you $500. And the new model is given their v equals c times b to the power of t plus d. And the asymptote, the horizontal asymptote of the new model is v equals d. Right?
Mm-hmm.
And no matter how old it is, means that we talk about the infinity for the time. And then the model approaches the horizontal asymptote, which means that v will be equal to d. But no matter how old your car is, the company will give you $500. So the value is counted to be 500, so d should be 500. Got it? Got it?
Yes, I got it, miss.
And now the new model is, again, you find it as you did it in A and B, but using this plus 500 at the end. So K will be equal, C will be equal to what? Having that V equals C times B to the power of T plus 500, use again the information that the new car is 8,500. So what is C then?
Isn't the same?
8,500.
It's not the same. Just a second. The new model is V equals C times B to the power of T plus 500. Now the new car is 8,500, so 8,500 equals CB to the power of T, to the power of 0 actually, because it's new car, plus 500. But this means that 8,500 minus 500 equals C times 1. So C will be equal to 8,000 in this case. And in 10 years, no, 1 year later, the value is 6,800. 1 year later, X8. So from c equals 8,000, this means that v equals 8,000 b to the power of t plus 500. 1 year later means for t equals 1. So 6,800 are equal to 8,000 times b to the power of 1 plus 500. So 8,000 b equals 6,300 and b equals 6,300 over 8,000. Which is 0.7875. So the answers of the question state the value of C and D. C should be 8,000 and D should be 500. Okay.
Okay.
Nice. Any other questions by now? We can, yeah, we have some more time. We can do something else. Direct and inverse variation. This is something we did in IGCSE. I hope at least some of you will remember it. And cubic models. Maybe we will not do cubic models today, but we'll see. Direct proportion. Two quantities are directly proportional when one is a constant multiple of the other. We can also say that y varies directly with x to the power of n. And all the following graphs show direct proportion. Even 3x is direct proportion, x squared is direct proportion, 4x third is direct proportion. Y equals to square root of x is direct proportion. The point is that when x increases, y also increases. But mathematically, this means that y varies directly with x to the power of n, which means that y equals kx to the power of n. When they say that y is directly proportional to xn, then the general form is kx to the power of n. And when x equals 0, y equals 0. So they always pass through the origin. And of course, as we did for the previous models, you need one pair of x and y values to find k because you have only one unknown coefficient. For example, if they say y is directly proportional to x3, when x equals 1, y equals 4, and then to find the value of y when x equals 3, y is directly proportional to x third. How can we write it as an equation? How can we write the first sentence as an equation?
Y equals x cubed.
Can you look at the above? If y is directly proportional to x nth, then y equals k times x to the power of n. Y is directly proportional to x3. How do we write it as an equation?
Y is equal to K times X3. Yeah.
And then we use the given values when X equals 1 and Y equals 4. And that's how we find K.
Mm-hmm.
So in this case, we will have Y equals 4x3, which makes it easy to find the value of Y when X equals 3. So at first you write the general equation, then you use the given values to find K, and then you substitute into the equation to have the real equation of the proportionality or the variation, and then you use it to find the value that they want you to find. Questions?
Makes sense.
Inverse proportion. It is almost the same, but it is K over Xn. The point is that when X increases, Y decreases. Again, you can have different graphs for this. Some of them are these ones. Like 3 over X, 2 over X squared, 1 over square root of X. It depends. In the first case, K equals 3, N equals 1. In the second case, K equals 2, N equals 2. In the third case, K equals 1, N equals 1/2, because square root of X is X to the power of 1/2. So when it's inversely proportional to X to the power of N, then the general form is Y equals K over X to the power of N. And the y-axis is always an asymptote of the graph of y against x, because y can never become equal to 0. And x can never be 0 because it's at the denominator. So how do we solve this one? Y is inversely proportional to x squared. How do we write it as an equation?
Y is equal to K divided by X squared.
Y equals K divided by X squared. There is a mistake in the question. When X equals 1, Y equals 4. So what's K?
One sec. So wait, which
It is when X equals 1, Y equals 4.
X is 1. Yeah, it's K is 4.
K is 4. So the equation is Y equals 4 over X to the power of N. And now find the positive value of X when Y equals 16. When Y equals 16, you will have 4 over X squared equals 16. X squared equals 1/4. Here, on the exam, you should write that X equals 1/2 or negative 1/2. And because they want the positive value, that's why X equals 1/2. Right?
Yep.
And the cubic models are very similar to the quadratic models, but they have also ax3 at the beginning, and they have 4 coefficients. And the graphs of the cubic functions can have 0 or 2 turning points. The first one has 0, the second one has 2 turning points. There's no way for a cubic function to have one turning point. Because if it has only one, it will be quadratic function. So, as with quadratic models, you can use given x and y values to find the coefficients, like in this one, but you will have 4 equations because you have 4 unknown coefficients. So for that one, when you substitute all of them, when x equals 0, y equals -5, when x equals 1, y equals -2, when x equals 2, y equals 7, And when x equals 3, y equals 34, you will get these 4 equations. You use your best friend to solve it. You find the coefficients. That's how you find the model.
Okay.
At first the model, and then you substitute it by 4. The point is that the number of the equations you will have corresponds with the number of the unknown coefficients. For the quadratic function, we had 3 coefficients, a, b, and c. We needed 3. To get 4 equations and to be possible to solve them. Questions? Okay, we are not going further. Any questions by now? Okay, I will upload your homework a little bit later and see you next week.
Bye, miss.
Bye, miss.
Bye, miss.
Bye, miss.
Bye, miss.
Presentation?
Huh?
Are you gonna upload this presentation? Because I would like to
Yes.
read over it.
Yes.
Okay. Have a nice day.
You too.